Okay. We're going to talk about energy efficiency in industry. So as an energy auditor or as an energy manager, your work essentially is to go into buildings wherever energy is consumed, go into the place, understand the flow of energy. Energy flows in so many forms, and and at the beginning we've talked about the various forms in which energy exists, the various types of energy: chemical, electrical, mechanical, and all other forms of energy. So it is your work as an expert, as an energy auditor, to understand all of this, and then be able to create measures, to be able to manage such that less energy is consumed, while achieving the same or even higher level of work or higher output. Okay. Okay, so we are going to go into all of those industrial applications in this class. At any point you feel that you're not following or you feel lost, please let me know. Perhaps I could explain in another way, just to make sure that everybody is carried along, and that the impact, I mean, that you actually get the value for this training, such that I'll be happy to hear that. I mean, in a few coming months, that some of you will have been able to like I said in the last class, these things practically can start from your homes, because everybody consumes energy in their home. You can start from your homes, and you might even want to start, offering some free energy audit to some, small scale industries around your environment. Maybe pure water production companies, bakery, some of those small scale industry that you can easily have access to, and with minimal equipment. But some of them energy, like if you go to bakery, they have energy intense equipment, but of course the energy consumption might not be so. But some of those things you might even start from there, and then from there you can begin to work along with industrial energy audit, where you can begin to go into industries and you begin to conduct this audit. So as part of energy management, energy audits have to come in for you to manage energy efficiently. You need to first of all audit. Audit means that you need to understand the flow of energy. Okay, so let's get this started. I just give this objective. Okay, so as an introduction, so the goal of energy efficiency, we're going to be dealing more on energy efficiency. So the goal of energy efficiency program is to maximize the productivity of energy by keeping waste as low as possible, thereby increasing business profitability and providing solutions to environmental challenges, such as global warming. I've explained all these concepts in our previous classes. So it is an ongoing program that is actually never finished. So energy management is actually a continuous, in fact, in some cases, we call it continuous energy management practice or program. It's a continuous process. The thing is that if you conduct an energy audit, and this is where automation, not necessarily automation, but technology, this is where technology and energy converge, right? So if you conduct an energy audit and you find out that there's an inefficiency somewhere, and you make a recommendation for that inefficiency to be corrected, and eventually it was implemented and corrected, somewhere down the line, that system could still break down, because it's technology. It could still break down, and if there's no continuous monitoring, then what that means that the losses will continue. So it always makes sense that these things are continuous. If you don't have a technology to create a visibility to see the energy, right? What that means that you need to engage another consultant to check, why your energy bill has gone up. Yeah. So I can give you a typical example right from anywhere I am. I can, because I have panels. I mean, solar panels. I mean, in my house, right from anywhere around the world where I am, I can actually monitor what it is producing and what my house is consuming. That's technology, and sometimes I can literally tell you the things that are on in my house based on the dashboard, based on the monitoring system that I have. I can literally tell you what is on, and if certain things are on when they shouldn't be on, right? I can be able to make a call, just to find out what it is running. So this is where technology meets energy, and everything comes together to form a continuous energy management system. So back to the energy efficiency. It is actually, like I said, how you maximize the productivity of energy. Just the same way human resource management in every organization try to maximize, the human resources in that organization. Energy managers in any organization actually maximize, the productivity of energy that they pay, which is also part of their input into the production process. So energy efficiency is a practice of using less energy. Now, put it another way, using less energy to do the same amount of work. Engineer Uche, I think I lost Engineer Uche. Are you there?
Yeah, I'm with you. I'm with you. I'm with you. I'm with you.
Yeah, you came in and you knocked off my screen.
Sorry, you can share now.
Yeah, you need to give me permission to share. Okay, yeah.
You can share now, sir.
Okay, okay. Okay, yeah. Sorry for that interruption. So put in another way, energy efficiency is the practice of using less energy to do the same amount of work, or even doing less, or using less energy to provide, the same quality of service. Using less energy should not translate into less quality of service or into less quality of product. Example including replacing your 60-watt rated incandescent lamp. The incandescent are those yellow bulbs, those old, kind of lighting bulb that we have. Replacing them with a 12-watt rated LED, light emitting diode. That's what LED means, light emitting diode. It's an electronic lighting system. So you can replace your incandescent bulb, which is more of a heating system. It has a heating filament that has more like a resistive load, right? So changing that technology now to the new technology, which is a 12-watt rated LED bulb. When you do this, you've actually implemented energy efficiency. Now, to enable citizens to understand energy efficiency better, many countries have introduced energy efficiency labels and rating. Fortunately and unfortunately, for Nigeria, fortunately in the sense that we now have those kind of labels. For cooling system, with the support of Foreign Development Agency, we now have those kind of labels for Nigeria. But unfortunately, because I can't see them already in the market. Yes, we have them, but when you go to the market, when you want to buy air conditioning system, when you want to buy a refrigerator, I don't see them already. So it's that these things already exist, but they are not fully implemented, right? So now these are the examples of those kind of labels. Now in America and some other parts of the world, you're going to have something like Energy Star. So depending on its efficiency, the number of stars helps you to, the more number of stars it has, the more efficient it gets. Now that's Energy Star. Then the second one is the one of Nigeria. Now this is the rating for Nigeria, building energy level. So we have this already existing, not for all equipment. I know for air conditioning systems and refrigerator, I don't know if it has been extended to other equipment, but for this air conditioner, yeah, we have it, but I don't already see them implemented. Then you have the third one. I think this is for India. I'm not so sure, but I think it's for India. Then this other one, I think it's for Europe. So just to give you an example of what energy efficiency label looks like, okay, and that's why I'm having these pictures to illustrate. So energy efficiency labels are logos or ratings used to designate or describe the energy consumption characteristics of a device or system. Now, this designation from trusted agency means that the appliance exceeds minimum performance standard. It meets minimum energy performance standard, usually by significant amount. Products without these labels are most likely inefficient in energy consumption. So this is the purpose of having the energy efficiency label. In some appliances, I think I've seen some TV, in fact, they will tell you that if you watch this TV for this number of hours in 1 year, this amount of energy you're likely going to consume, just to give you that information. So if you're out there in the market, to shop for this electronics, it's a guide for you as a consumer, on how you're going to manage your operating costs. Because when you buy the equipment, you're doing the initial capex, then there's still opex. It's giving you an idea of what the opex would look like, right? So you'll find out that some of those equipment that are more efficient, they might cost a little bit higher, but you're going to save a lot, but in opex. Okay, so it's just to educate you so you can actually, see which one makes sense for you. Then some of the logos and ratings are already they're already displayed up there for us to see. Okay, so now let's look at the primary causes of inefficiency. What are the primary? So if you have your light bulb, mind you, even the light bulb that we have today, the energy efficient light bulb that we have today, the LED light bulb, does not mean that it is 100% efficiency, right? It doesn't have 100%. So it still has some level of inefficiency, right? But of course, it has been reduced significantly. So, but again, the question is, what actually are the causes of this inefficiency in any system? What are the causes of this inefficiency? So there are two primary factors of inefficiency, right, in any system that you can think about. And there is a human behavior factor, and then there's a technical factor. The technical factors is what we know as the technical losses. Okay, we are going to talk about this in a bit. But before that time, let us look at, how does this come together, to affect the energy balance system. So that takes us to an energy balance equation, right? So in an energy balance system, essentially, as an energy auditor, what you're actually doing, you're doing energy balance as an energy auditor. So you have to look at all the energy that's coming into the building, and you try as much as possible to account for how all of this energy leaves that building, how the energies are expended. And that's what you do as an energy auditor. The same way a financial auditor will come, they will look at the inflow and how it's, they will look at the inflow and the outflow, and then try to see if the outflow actually, is incommensurate with the inflow, or if there are inefficiencies, if there are leakages in the financial system. So as an energy auditor, that's essentially what you're also trying to do. So you need to understand energy balance equation to be able to do this very well. And in an energy balance equation, you have energy that is coming into any system, whether buildings, manufacturing system, or process. In any of them, so whatever energy that is coming in, it is equals to the energy that is used. Energy that is used usefully. So energy can be used usefully, or it can be used and it is wasted. So it is equal to the energy that is used usefully plus energy that is used that is also wasted plus losses. Okay, so if you take an example, a light bulb for an example, when you flip the switch of a light bulb and the light comes on, right, and there are people in the room, right, it provides that the electrical energy that is coming in is converted into a light form of energy, right, and it provides visibility into the room, and there are people there who could actually use it to do meaningful work. But imagine now that is energy that is used usefully. But imagine if there's nobody in that space, there's nobody in the room, and then the light is on, right? Now the energy is actually used, but it is wasted. Okay, just to give you an example, what energy used usefully and energy used wasted means, right? So if there are people in the room, it is used and it's useful, but if there's nobody in that space, then it is used but wasted. So that's the energy wasted, and that's the energy. So I give you another example for an air conditioning system. Now, air conditioning system essentially is used to do a climate control in-house. I mean, within a space, right, to control the climate in terms of the temperature, humidity, right? Now, if there are people inside that place, then you're running an air conditioning system. Yes, you bring the climate of the space to a comfortable level where the people can feel comfortable, right? And they're not sweating, they're more relaxed, they can think properly, they can do their work, yeah. But imagine if there's nobody in that space and the air conditioning system is running. The energy is used, but it's not useful because there's no production, there's no meaningful activity that is going on within that space. It is also possible that you could have a storage, I mean, maybe a storage facility where you might need to control the temperature. Yes, in that case, it's doing a meaningful work, but whereby you can't point to any meaningful work that is happening. In that case, it is wasted. Then there are technical losses. I explained this when I was talking about electricity, when we are talking about electrons flowing through the cables. There are resistances. right? But the electron need to overcome those resistances. While trying to overcome those resistances, they get heated and they turn to heat and they are dissipated into the environment. So those are technical losses. You cannot avoid them, completely, right? But they can be minimized by the right design. You can actually minimize them. Okay, so now the human behavior. Okay, so the energy that is used, that is wasted, right? Mostly as a result of human behavior, because somebody may have flipped the switch, somebody would have turned on the air conditioning system, or somebody may have left the machine idle, running, consuming energy without doing any meaningful work. So most of this, they are human behaviors that results to the energy that is used but are wasted. Right now, the energy that is the energy losses that are technical are what we know as the technical losses. I've explained this already, so I think I can go on to the next slide. Do we have any questions so far? No, fantastic. So let us look at another equation. Right now, this is end user primary energy efficiency measure. Right, a lot of times we've in the same way, some of us, even some of us who are, technicals, sometimes we mistake energy efficiency with energy conservation, right? So these are two different things. Energy efficiency is different from energy conservation, and I'm going to explain that using this equation. And the reason why I'm trying to, okay, somebody raised his hand. I have an issue from my end. Multiple names are showing on my screen using the same name as Cis Fabinu, multiple names. So I don't know if the person who is raising his hand is the actual assist or a duplicated assist. I don't know. So, but please go on and have the mic.
Yes, good morning. My name is Dr. Shoma. I just want to ask a question regarding those labels. I know those labels, I'm in the building services environment. Those labels, we have them in the market. Is there any synergy between where these labels originated from and Standard Organization of Nigeria? Because they are, tasked with the responsibility of checking compliance and all that. How do we, because these labels, people, anybody can print it. Is there any synergy for us to be able to truly identify? Because there are a lot of air conditioning that you say they are inverter type, they are class A, class B, and all that. But how do we know all this authentic, if these things are authentic?
Okay. Thank you very much for the question. Like I said, we have this thing in Nigeria. We have some of these labelings. I think where we are lacking is in terms of implementation, or in another word, enforcement. And I think this is where Standard Organization of Nigeria have to come in. And again, of course, we cannot do the work for the government. That's why we put them we employ them to do the work. At the point where these things are coming into the country, we expect that they would have gone through verification and clearance before they are allowed into the economy. But again, if these things are not working out exactly the way they should, then the government have to, especially the government agencies who are responsible for this, have to sit up and do the work. But ideally, some of them, if they're coming from a trusted country in terms of the origin of manufacture, it is expected that they meet with some of these standards. So, for example, I think part of the reason why a lot of manufacturing can be done in China is because they have this loose regulation that allows any standard, to be manufactured. So if you just oppose that with products that are manufactured in some other country, like maybe Canada or US, no matter the country where you're exporting those products to, they must meet, as long as you're manufacturing in the US or in Canada or in whatever country, they must meet their own standard. I can't, but I think this is what it is, right? So sometimes in Nigeria, what we also do, we put some of these things to test. So, for example, if you have solar panel, maybe we can talk about this when we get to solar panels. You can see so many panels, solar panels. people can put whatever sticker they want on solar panel. They can get a 300-watt solar panel and say it's 450-watt solar panel. How do you know? So maybe we're going to talk about this, so we'll get to solar panel, but we're not there yet. Okay. So in some of these things, if you're
give me headphone, you refuse to give me headphone.
Please, you need to mute yourself, please. So if you're not speaking, please mute yourself. If you're, except you want to share iPhone for everyone who's participating in the class. Okay, thank you. So I don't know if that's answers your question. Like I said, it's the responsibility of the government to make sure that these things are controlled. Also to protect the citizens from exploitation, whereby some scientists will not meet some certain standard, but they will be misleading with these levels. I think it's the responsibility of the government. Okay, let me just continue. I guess that answers that. So we are going to talk about the energy consumption. I was talking about the difference.
Is that what?
Please mute yourself.
I know, yeah, you. Yeah?
Oh my goodness.
How do we go?
Somebody's mic is on.
Please. I'm really struggling to get a point where I can mute everyone. I'm not very conversant with these tabs, the button tabs in Zoom. Well, I'm really struggling to get that point where I can just mute everyone without disrupting my screen.
It's the only for to come.
So on that note, I want to plead with
so now
please mute yourself.
Mama Clara now, they say she come on her own. So she go back. Then this brother and his wife, I called him this morning. He said, "Now,
somebody tell me where to mute
your mic is loud.
I'm
your mic is
to get
loud
that from the tab.
Hope it's not my own. Okay. Let me off my mic. They can't find another place.
And the co-host just mute me.
If anyone knows very well where I can get the mute button, so I can mute everyone. I'm really struggling to get the place where it is on Zoom.
Good morning, sir.
Good morning.
Sorry, I don't know why this is the real Fabino Aziz speaking right now.
Okay.
I don't know why I'm seeing so many Aziz Fabino on the screen. Because the last person that was not muted brought Aziz Fabino when he was speaking. So I don't know why it is bringing Aziz Fabino, because this is the real Aziz Fabino talking.
Hey, yeah, sorry about this. I think it means that they copied it from your link.
Yeah, okay.
Sorry, what I would suggest people should do, everyone should check and confirm if your name is appearing as Aziz Abino and you are not Dua, rename it to your actual name. That will clear the whole thing, so that whoever is talking, or if there's any interference, we know exactly who the person is. So people should please check and rename what's appearing as their name if that's not the actual name. Thank you.
Thank you, Dr. Suleiman. I really appreciate that contribution. Please, can we just please adhere to this instruction? If the inscription on your tab, it's showing as is Fabin that is not you, please, can you just go and modify it to your name? It's modifiable. Modify it to your name so that we don't have so many assists. Like I've made this complaint. I really don't understand why I'm seeing so many assists on my screen. Please, can we just adhere to this instruction so that we'll know who is speaking, please? Okay, and if you're not speaking, please kindly mute yourself. So the time we are wasting, trying to address some of the issues at the time that we could have used to, move on with the training, and we have a lot to cover. Okay, so now I was trying to explain energy conservation and energy efficiency. These are two different terms. These are two different words, even though they are related. But they are two different words. But any one of them that you do, it's either you do either one or both of them. If you do any, actually saving energy. You're reducing energy consumption. So the end user primary energy efficiency is what we're talking about today. So reducing one or both variable. Now, what are the variables? Energy is, so remember, energy is kilowatt hour from the energy basic that we did. Kilowatt, kW, and hour, H, right? Now, if you split that, what that means that energy is power times time, right? So if you reduce the power in terms of kilowatt needed to achieve the same result, if you're able to reduce the kilowatt, what you have actually done is you have actually done energy efficiency. And this example of this is a light bulb that I always make a reference to. If you change your incandescent lamp bulb to an LED, what you have actually done is you have reduced the kilowatts. Normally, those incandescent bulbs are usually about 60 watts. Now you remove that 60 watts, you replace it with 10 watts. You have actually reduced the power and you have actually achieved a lot in terms of energy efficiency, right? Now, that is on one hand. On another hand, you could replace 60 watts with that 10 watt LED bulb, right? And again, that LED bulb could be on when there's nobody in that space. So it's still an energy, in as much as you have achieved energy efficiency, but more could be done in terms of the usage. There's nobody in that space, but the 10 watt LED bulb is still on. There is an energy waste. So if you're able to switch it off when there is nobody in that space, then what you have actually done is energy conservation. So reducing the energy that is in energy efficiency, the work is still being done. Energy is still being consumed. But in this case, you're using actually a lower capacity equipment to do the work, energy efficiency. But when you avoid the use of that energy for any reason, what you have actually done is energy conservation. So if you reduce the hours, you have done energy conservation. Some lighting bulbs come with a complete technology. So for example, in some of the lobbies in my house, what I have this, light bulbs that has sensors. So whenever it senses a motion, it turns on. So first of all, I have reduced their power demand by using an LED bulb. Now, because I don't want them to be on when there's nobody in that space, I have to make sure that they have sensors. So whenever there is any human presence, they automatically turns on. And after a few seconds, there's no motion, it turns off. So just using that technology, I've been able to achieve both energy efficiency and energy conservation. I don't know if this is clear, if it actually explains very well what energy efficiency and energy conservation means. And if you're able to achieve one or both of them, then you're actually saving energy consumption. Any questions so far? Okay, let's go on. So let us talk about coefficient of efficiency. I think in the previous lessons, we've talked about this. How do you measure energy efficiency? So it's actually the useful energy divided by the overall energy input. Okay, this is the formula for efficiency in any way. Okay, two people raised their hand. Can you go on, please?
Excuse me, your screen is not showing anymore.
My screen is not showing. Oh,
yes.
Really? Okay. Oh, I don't know. Okay. Thank you very much for letting me know about that. Is that the same for everyone? No, nobody see my screen?
We're not seeing your screen. I'm not seeing your screen.
But it seems like
I can't see your screen. It's off.
I can see. Mine I can see from my.
Your screen is paused. Maybe you need to remove it from being paused.
Let me do this.
You have paused your screen sharing.
I'm sorry. Yeah, I'm trying to reshare it. I think it's why I was trying to mute, some mic, and I don't know. Maybe I clicked the button and it was paused. I didn't know, and that's the reason why I say everybody should just please mute yourself, so I don't have to do this from my end. My apologies for that. I didn't.
Okay, it's up now. It's
okay.
Up now.
It's up.
Okay. So this was the last screen that you saw, right?
No. Yes, this was the last one.
Oh, this was the last screen that you saw, the primary causes of inefficiency. Oh, sorry.
Yes.
Okay. So I was actually explaining this very screen and these primary energy efficiency measures, where I talked about the power and the hours. You know, do I need to go over this again? So what this means that if you're able to reduce the power consumption, please mute yourself now if you're not speaking. So if you're able to reduce the power consumption of your appliance, so for example, I use the light bulb, for example, if you change your 60-watt incandescent light bulb, you change it to 10-watt LED, what you have actually done, you've reduced the power. In that case, what you have actually achieved is energy efficiency, right? But if you have done that and the 10-watt LED bulb is still on when there's nobody in that space, right? There is still waste, it's still an energy waste, okay? So what you need to do is to turn it off when there's nobody. So when you turn it off, then you've actually done what we call energy conservation, right? So energy conservation is the reduction in the hours of use of the equipment, while energy efficiency is in the reduction in the capacity or in the power demand of the appliances or the appliance. That's what, you know, that's the difference between energy efficiency and energy conservation. So let's go into coefficient of energy efficiency. I mean, the formula for efficiency is the same almost everywhere. The useful output divided by the overall input, right? So in terms of energy, it's usually the useful energy divided by the total energy input into the system. And how do you calculate the useful energy? It is actually the total energy that goes into the system minus the losses. Now, these losses include the technical losses and the human and losses resulting from the human behavior. When you do that, you can then actually see the real efficiency of energy of the system. So if you take an example of a power production, maybe a power plant. So for example, let me ask every one of us, what do you think is the efficiency of a diesel generator? Now, what I mean by efficiency is that when you get a liter of diesel, now, to give us an idea, 1 liter of diesel contains about 10.7 kilowatt hour of electricity. I mean, if you convert everything to electricity, it contains about 10.7 kilowatt hour electricity. How many of that do you get from 1 liter of diesel? I mean, I want to get a feedback.
Hello?
Yeah, go on, please.
And there's nothing on my screen, no.
Really?
Yes.
Is that the same for everyone?
Post the screen sharing.
It is your network. It is your network.
No, it's fine here. No,
I
that
can
is
see the
his
screen.
network.
Yeah, the screen is fine.
We still have coefficients of efficiency on our screen.
Okay, yeah. So
Yes.
if you're not seeing my screen, then I think it's probably from your network. Okay, now, unless you want to speak, please mute yourself. I asked a question, and I gave a background that a liter of diesel contains about 10.7 kilowatt hour of electricity. So if you have, assuming you achieve 100% efficiency, what that means that for every liter of diesel you consume through your diesel generator, you're actually going to get 10.7 kilowatt hour of electricity. But in reality, how many do we get? What is the efficiency of a diesel generator? I mean, can we just have... Sorry, you said what?
25%.
25%. Okay. Do we have any other opinion? Okay. So what is the efficiency of a petrol generator? What do you think is the efficiency of a petrol generator? Any attempt? Okay, let's not waste time on this. So for these generators, it now depends on the state of the generator actually. This generator can be as efficient as 35%, as efficient as high as 35%, but I don't think anyone can be more than 40%. But if everything is superb, right, it can be as high as 35, maybe 36, but on average 35%, right? But if the diesel generator has some issues. So for example, if it is underloaded, it's not properly maintained, then the efficiency can drop as low as maybe 25 or thereabout. So it can go down up to that level. So it all depends on the operating standard of the equipment. But that is actually what that means. So out of the 100% electricity that you could get out of every liter of diesel that you consume, you're only getting about 35 or 30 or 25 as the case may be. So this is something that we as an energy auditor, when you go out in the field, you have to be able to measure this. And how do you measure something like this? You measure, I know for many of us, we don't meter our diesel generator. I mean, what the electricity is producing, you don't have a meter for that. But if you need to do an energy management, it becomes important that you measure that. So if you're able to measure that, what you're going to do is to measure the quantity of diesel that it's consumed, and then compare that with the electricity that it's producing. And like I've said here, the estimated energy content of a liter of diesel. And this also brings in the question of the quality of the diesel. If you have a good quality diesel, you can actually get more. And this is where many people don't look. I know for some businesses, when they bring in the diesel, they actually check the quality. They look at the viscosity and look at the density and some other things. I mean, you check the quality of the diesel, but in some places they don't. I mean, diesel is diesel. It is not. Diesel is not diesel. There are some poor quality diesel. So as an energy manager, you also need to know, imagine that a supplier has been shortchanging you by supplying you a poor quality diesel. What that means that you're actually burning more quantity of diesel with less electricity output, and you're spending more. So as an energy manager, you also have to take notice of this. What quantity of diesel are you spending? What are you getting out of it? You take measurement, then you do your calculation, then you can see what you're actually getting. Can you do better? Can you have a better deal? Do you have somebody who can actually supply a better quality diesel? Can you improve on the maintenance of your diesel generator? All of these are things you can suggest to improve the efficiency of that power generation system. Now, I'm saying all of this to explain, the coefficient of efficiency and what it means. Now, let's go into the energy efficiency in industries, the applications of energy efficiency in the industries. So when you go into an industry, what are you likely to see in the industry? You're likely to see a lot of motors. You're likely to see a lot of cooling systems. You're likely to see water pumping system. I mean, maybe what do you call them? Compressed air system. I mean, all of these are what you can see. You can see boilers and heat distribution system. So please mute yourself unless you want to ask a question. So we're going to go through all of these applications, and then we're going to talk about the technologies and the energy system so that you can be able to understand how they consume energy and things to look out for when you go out to this industry. So let us start from the very base, which is fuels and combustion. A lot of time, this is where energy combustion starts their journey, because most of this energy starts their journey in the form of chemical, which is maybe petrol, diesel, coal, whatever it is, and they need to be combusted. They need to be burnt, to free up, the energy they have, and those energy have to be converted into different forms of energy. So let's take example, your diesel generator or your petrol generator. Let's take petrol generator for an example. The petrol gets into the combustion chamber, and it gets burnt to free up the energy. So it's converted into thermal energy after the fuel has been burnt. That thermal energy is used to drive the piston, okay, which is a mechanical energy, right? Now that mechanical energy is now used to turn the armature, that is the motor, the armature, which is now actually producing the electricity. So you are now converting from chemical to mechanical to electrical, which is now the output. So in all of these processes, you have losses. You have energy loss in all of these processes. And that's why the efficiency of a petrol generator is actually lower than that of diesel generator. But let's just come back to the industrial application. So combustion is simply a chemical process of converting hydrocarbon fuels to thermal or heat energy. It's a chemical process. I mean, it can be represented by a chemical formula, okay, which is as simple as CH4 is methane. When you burn hydrocarbon, or in this case, methane, hydrocarbon is a compound that has carbon and hydrogen, as part of the component, yeah. So CH4 is methane. When methane is gas, okay. So when you burn gas in the presence of oxygen, okay, what you're actually going to have as an output is carbon dioxide plus water. Water comes out in the form of water vapor. You will actually see it. Then plus the heat, which you can then use to now heat your water. In the case of boiler system, you use that heat to convert your water into steam. In the case of domestic applications, maybe your cooking gas or whatever, the heat is what you actually use to cook your food. So it's a chemical process. So let us look at the combustion efficiency, okay? Now, there's what we call complete combustion, and there's an incomplete combustion. Now, a complete combustion is where you burn all the fuel. Now, remember, in your combustion process, where we talked about is what we said is a chemical process. Now, if you have, for example, if you have 10 kilograms of gas that is coming into your combustion chamber where it needs to be burnt up, and so burning up means that you're going to split it up and release all the energy that it contains. But if you're not able to achieve complete combustion, what that means that some fuel will go out without releasing their energy. So it impacts on the efficiency of this process, of the combustion process. So the goal of a combustion is to make sure that you achieve a complete combustion. So what are the things that we hinder a complete combustion? If you don't have, let me go back to that equation. If you don't have sufficient oxygen, right? If you don't have sufficient oxygen, you will not achieve a complete combustion. So this methane will not achieve a complete combustion, right? And if that happens, what you're actually going to get here is carbon monoxide. Carbon monoxide. So carbon monoxide becomes an indicator that we use to know when there is a complete combustion or incomplete combustion. We are going to come to how to test for that. But for now, we are dealing with combustion, and we want to know what is a complete combustion and an incomplete combustion. Now, if you look at these flames, the flames number one is a typical, in fact, it shows you that there is an incomplete combustion. An example of this kind of combustion are firewood. You will know that firewood, you can hardly, burn everything up, right? And that's why you see this kind of yellow flame. So it's an incomplete combustion. Now, a complete combustion is a typical example of your gas, your cooking gas, that is efficient, because some of them are still inefficient. When you see all these blue flames, then you know that yes, there's a complete combustion. So how do you know a complete combustion? The flame is blue, there is no residue, and that's why you see your pot, your cooking pot. When you're cooking with gas, you don't see black spots on your pot. It's an indication that yes, there's a complete combustion. Now, when you compare that with firewood, you actually see all those black residues, which means there's an incomplete combustion. So for a complete combustion, there's no residue, the temperature is high, and it's high, it comes out with a high efficiency. Now, for incomplete combustion, you begin to see all those yellow flames or orange flames. You have a black residue, low temperature, energy is wasted, and there's also, in some cases, toxic gas that are produced, which is the carbon monoxide. CO stands for carbon monoxide. So what is a complete combustion? To ensure complete combustion of the fuel used, combustion chambers are supplied with excess air. Now, remember that it must have the sufficient amount of air to achieve a complete combustion, but you wouldn't know the right quantity of air that is required. So the idea is to slightly supply a slight more air that is required. So, and that's where the concept of excess air comes in. So you supply a little bit of more excess air to be able to make sure that at least you achieve a complete combustion. But if that excess air becomes too much, you also begin to reduce the efficiency. We're going to see that in the diagram. So excess air increases the amount of oxygen to the combustion and the combustion of fuel. When fuel and oxygen from the air are in perfect balance, the combustion is said to be stoichiometric. Stoichiometry is a scientific term. So the combustion efficiency increases with increased excess air until the heat loss in the excess air is larger than the heat provided by the more efficient combustion. We're going to see what that means. So this diagram typically illustrates that. So if you move to your left, it's an excess fuel. If you move to your right, it's an excess air. And in between, that's where you have your stoichiometric combustion. That is your most. Now, look at the efficiency. The red line is the efficiency, right? So this is the efficiency, right? Now, the efficiency begins to drop the more you begin to add excess fuel. What that means that some fuel will not be combusted. So the efficiency begins to drop. Now, if you begin to increase the excess air, which means you are increasing more of the oxygen, right? So what that means that if you add excess air that is unnecessary, the efficiency will also begins to drop, because some of the heat will leave with the air, and as the air is going out, some of the heat will have to leave with the air, right? So there has to be a balance somewhere, and this is the percentage XX that is required for the different kinds of fuel. So if you're using a natural gas, if maybe for an industry, most of this industry, they use gas, to power their boilers. We're going to talk about the purpose of boilers and steam in the industry, but now this is a primary, this is where the journey of that, of the whole process starts, and that's why I want us to understand this. So if you're using fuel oil like diesel or some other form of heavy oil, it is required that you introduce about 25 to 20% excess air. Then if you're using coal, it is expected that you introduce about 15 to 60% excess air, to be able to achieve that complete combustion. Now, I talked about measuring the efficiency of a combustion chamber. How do you know when there's a complete combustion or incomplete combustion? Now, there's equipment called combustion analyzer. Okay, you can see that on the screen. Is a combustion analyzer for most of the boilers in the industry. The exhaust pipe or the stack. Some of them, they usually have, they actually have a hole. It will be covered anyway, but you just have to find a way to stick the probe of this combustion analyzer into the exhaust pipe, and this exhaust pipe, this combustion analyzer, we analyze the exhaust, that is the air that is going out through the pipe, and this combustion analyzer will not determine if there's a carbon monoxide or not in the outlet chamber of the air, right? And it's going to tell you. So the moment you begin to notice carbon monoxide, then what that tells that there's an incomplete combustion, right? So this is a tool that is actually used to it also measures some other forms of gas to know if, for example, there are some harmful gas that is actually going out into the environment. So this is something that actually tells us a lot about it. Now we've talked about combustion. Now let's talk about boilers. Now combustion chambers are actually inside a boiler. So if the boiler is housing the combustion chamber, right? Yeah. So now the essence of the boiler is to convert water to steam. Now, steam is a form of thermal energy. It's a form of heat energy that is used in the industry. If any production material needs to be heated, if any production material needs to be, the temperature of any production system needs to be raised, right? Then how do you take the heat to that production system so that you can raise the temperature? That is where boiler comes in, and that's where steam comes in. The same way you need electricity to drive your motors. You need to have an electrical network in your facility to move electrons to your machines. The same way you have the heat distribution system in the industry that will move the steam to the equipment where they are needed. So the essence of boiler is to provide or to produce steam in the industries. Now there are two kinds of boiler, two basic kinds of boilers anyway. So there is water tube boiler and there is a fire tube boiler. I don't want to spend so much time here. The name explains itself. Now for water tube boiler, you can see that water, now this is the boiler itself, right? Now these are the tubes. The blue pipes are the tubes, right? Now you can see that water is moving through the tubes. Okay, so as water moves through the tubes, this is the combustion chamber. This is where the combustion is taking place. So the entire space here is heated to a very high temperature. So as water moves through these tubes, now these are metallic tubes. So they absorb heat. They absorb the heat from this combustion, and they use that heat to change from water to steam. And when they are coming out here, they are coming out as a steam, no longer as water. They are coming out as steam. Steam is like a gas. So they are coming out like a steam, very hot steam that are coming out. And from here, you can now pipe it into your different industrial applications. So for example, if you're manufacturing milk, there's what we call pasteurization in the production of milk. For you to do pasteurization, you need to provide heat to that milk. So people who harvest maybe cow milk, okay. I know in some part of Nigeria they harvest those cow milk and they just drink it without without purifying it. So pasteurization is a process of exposing that milk to a high temperature just to kill any harmful bacteria or whatever it is. So that's the process of pasteurization for milk production. So there are so many applications of such nature in industries, right? So this thing will now be used to achieve that or accomplish that process. So this is water tube boiler, and then the second one is fire tube boiler. Fire tube. So as the name implies, fire is the one that is passing through the tube. You can see that this is the drum, this is the combustion chamber. Now, the heat produced from the fire is passing through the tube, right? And the water is just, here in the drum, and the water gets heated and it leaves as steam, just like, in the first case, right? So these are the two kinds of boilers that we have. Now, this is what is happening inside the boiler. I don't think I need to explain this. I explained it before. I have explained it again. And it's very important that we understand how water changes phase with temperatures. Water changes phase with temperature, right? So if you keep heating water, once it gets to 100, right, you keep applying heat to that water, but the temperature will not increase. All the heat that you're applying at that point is used to change the phase. It's used to change from liquid to gas. So it now converts to steam. Now, steam is water in the form of gas. And that is what you now use to, distribute around your industry. Now, you also need to understand the heat flow equations. How does heat from the water, how do you raise the temperature from the water to the point it becomes gas? And how do you measure the energy content of the water? How do you measure the energy content of the gas when the water has now become steam? How do you measure the energy content? How do you measure? All of this is what what we need to do with heat flow equations. Okay. Now, remember I talked about sensible heat and latent heat. I talked about this in our previous class, and there was a reason why I have to focus on them, because it is actually required. Now we have to deal with these equations. Now, sensible heat are the heat that you can feel. When your kettle is boiling, you take your hand closer, you can feel the heat. That is sensible heat. But once that water gets to 100 degrees centigrade, you keep applying the heat, but the temperature will not increase beyond because 100 degrees centigrade is the boiling point of water. So once it gets to that 100 degrees centigrade, it begins to turn to steam. Once it turns to steam, at that point, what is actually happening is latent heat of vaporization, no longer sensible heat. So there are different equations to calculate this. So if you want to calculate a sensible heat, so if you want to heat water from, for example, the water that is coming in from your pipe is, for example, 30 degrees, but you want to heat it from 30 degrees to 80 degrees. That is sensible heat. It's still water. How do you calculate the energy that you've added to that water? If you're using electricity, how do you calculate the energy that you've converted or that water has absorbed? Because at that point, the water is containing energy. How do you calculate that energy content of that water? That is what these equations help us to do. Okay? Even when the water has been converted to steam, how do you calculate the energy content of that steam? That's what these equations helps us to do, right? Okay, so if you're calculating for sensible heat, this is the formula you're going to use. So this Q represents heat flow. The M represents mass flow rate, and you can see the units, kilogram per second, the mass flow rate. So for every second, what's the volume of water that is passing? That is mass flow rate. There's what called CP. CP stands for specific heat capacity. Specific heat capacity of the water. Okay? Specific heat capacity is simply the amount of energy that the water can absorb when you raise it by 1 degree centigrade. Okay, when you raise 1 unit of water by 1 degree centigrade, how much energy can it absorb? I think for water is about 4 point something. And water has the highest specific heat. Water has the highest specific heat at 4 point something. But that's by the way. What you need to understand at this point is the specific. And like I've said before, you don't necessarily need to cram these formulas. You just need to understand, and that's why I'm taking my time to explain. You just need to understand when you can use them and how you can use them. You can always go back to the internet or to the textbook or to pull the formulas, but you need to understand, the definitions, so you know when and how to use them. That's the most important thing. Okay, so now this CP stands for specific heat. Now this we call it delta T. This now looks like triangle. We call it delta T, and what delta T simply means is a change in enthalpy or change in temperature. So delta T means change in temperature, right? Change in temperature. So if you're raising the water from 30 degrees, you want to heat that water to 90 degrees. You don't want to heat it on. So normally, the water we used to bet, the normal betting water should not be more than 60 degrees. If it goes above 60 degrees, it becomes harmful to human. So your heater in your bedroom should not go more than 60 degrees. At maximum, it should not exceed 60 degrees. So the water is coming in maybe at 25 degrees or 30 degrees, and that heater heats that water from that 30 degrees, it raises it to 60 degrees. Now the question is like, what is the energy that has been pushed into that water? What extra energy have you now added to the water? And that's what this thing helps you to calculate. So in industries, it is needed so that you can be able to account for the energy used in the industry. Okay. So now for latent heat, and as well as, so if the water is changing from liquid to gas, then you can use this formula, sensible heat and latent heat. This second formula is equal to, this quantity of heat is equal to mass flow rate times delta H. This delta H means change in enthalpy. That's what it means, change in enthalpy. Now, what this simply means that for every kilogram of steam, remember we're not talking about latent heat, right? Every kilogram of steam, how much energy how much energy in kilojoule? Now the unit of energy here is kilojoule. How much energy in kilojoule does every unit of steam contain? That's what it simply means. Then you multiply it by the volume of this, the volume of or the flow rate of the steam. Then you'll be able to know the quantity of energy that the steam is actually containing. Now there's another way. There's another formula, which is the third one, which is the heat flow through surfaces. Now, when you have a building, the reason why you need an air conditioning system in your building is just so that you can throw out the heat inside that building. Your air conditioning absorbs the heat in your space and dump it into the environment. Now, the question is, how does your indoor space, how do they absorb the heat into the space? You have closed all your windows. It's recommended that when you're running your air conditioning system, close your windows. Now you've closed all your windows. How did the heat get into your space? So the heat into your space could be from your television, it could be from your human body, it could be from your lighting point. But again, some of the heat are coming through the walls from the sun. They are penetrating through the walls and they are getting into your house. So you need to calculate that the volume of heat that are penetrating through your walls or through your windows or through the roof that are coming into the space. How do you calculate that? That is what this formula helps us to do. Yeah. So this now, is someone asking a question? Okay, please mute yourself. So this U that you see here is coefficient of heat transfer. So every building material, today some of us, you're going to be hearing about efficient building. How do you make a building efficient? For some that are into building development or urban planning, you'll be hearing about efficient building. So every material has a coefficient of heat transfer. Whether it is your window, if you go abroad, you begin to see double glazed, double glazed window, right? So if you have a double glazed window, they have their coefficient of heat transfer is low. So they are more like they have high tendency to resist heat, right? So if you have the kind of windows that we have here in Nigeria, which is just a single glass, their coefficient of their tendency to transmit heat into the building is higher. So how do you calculate that heat transfer through the windows, through the wall, through the roof? That is what this formula helps us to do. Okay. Now the A here is area. what is the roof area, what is the window area, what is the wall area. Okay, you multiply it by the change in temperature. What is the internal temperature inside house? What is the external temperature? That's the temperature difference that you can put here. Then you now look for the specific heat coefficient of the material, whether it is building block or glass or whatever it is. You go and look for it, and then you add it and then you multiply. Then you get your heat transfer through that surface. So these are the formulas that are needed. So let's talk about energy conversions. You know, when we started, I told that energy is measured in kilowatts. But many times when you go to industry, you find out that kilowatts is nowhere to be found. You begin to hear about megajoule, kilojoule. Okay, so how do you actually, and if you need to do your energy audit, you need to bring everyone to a base unit, and a lot of times the base unit is usually kilowatts. So how do you move around these units? Okay, so this is what this table helps us to do. So 1 kilowatt hour is equal to 3.6 megajoule. 1 kilowatt hour is equal to 3.6 megajoule. Now, let me ask a question. 1 megawatt hour is equal to how many kilojoule, not megajoule? Now, this is megajoule, right? If you convert this megajoule to kilojoule, 1 kilowatt hour is equal to how many kilojoule? Maybe one or two answers, please. I mean, can anyone respond to this?
Please repeat your question.
If 1 kilowatt hour is equal to 3.6 megajoule, then 1 kilowatt hour is equal to how many kilojoule? So convert megajoule to kilojoule.
3.6
times 3.6 times 1,000.
So what do you get?
3.6 times 1,000. That would be.
So that is 3,600
kilojoules.
Exactly.
Yes.
So let us be mindful of this unit. Megajoule. If you're converting from megajoule to kilojoule, you multiply by 1,000. If you're moving from kilojoule to megajoule, you divide by 1,000. Let us understand this, simple, but yet can be very complicating sometimes. So now for one meter cube of natural gas, this is the amount of energy it contains at 7 megajoule. 1 kilogram of type 2 fuel oil, this is what it contains. Now the question might be, okay, which one of these is diesel, right? I think diesel is the type 2 fuel. 1 kilogram of this number 2 fuel oil is 42 megajoule. Now this is for gasoline. This propane, LPG. So these are just different kinds of fuel and how you convert them. Again, you don't need to cram any of this. You can always go to the internet and you get the conversion factors. But it's good you know this. So this is just a quick test question. Heat which when added or subtracted does not result in change of temperature is called what? Just a quick answer. Heat which when added or subtracted does not result in change of temperature is called what?
Latent heat.
Thank you very much. It's latent heat. So another simple question. How much heat is required in kilowatts to raise the temperature of water flowing at 100 kilogram per hour? So for every hour, 100 kilogram of water passes through that pipe, and you want to raise the temperature from 20 to 100 degrees. Now, what kind of, which formula are we going to use? Which formula? Now, you're raising that water from 20 to 100. Which formula are we going to use?
The first one.
Is it, exactly. So thank you very much. It's a sensible heat. You're not going above 100. It's a sensible heat. So you're going to use the first formula. Please, you can just copy out this formula. I give you maybe 2 seconds to copy out the formula. You can copy out this formula so you can solve that question. You can solve that question, yeah. So I want you to use that formula to solve the question. Now, you have been given the specific heat of water. Remember, I told you that water has a specific heat of 4.2. Okay, so it has 4.2 kilojoule per kilogram per degree centigrade. So for every degree centigrade you raise water, if you raise water from 1 to 2 degrees centigrade, that's 1 kilogram of water from 1 to 2 degrees centigrade, you have actually added 4.2 kilojoule of energy into that water. Now, if you have copied that formula, it is asking you what is the heat required in kilowatt to raise that temperature from. So your temperature difference, your DT is 100 minus 20. Your mass flow rate is 100 kilogram. What again is required? Your specific heat is already given, 4.2. So you just do the calculation and let me know what you get.
33,600.
Thank you very much. So you get that, but now the question said, now this is the calculation, right? Now the question is a little bit tricky. 33,600 kilojoule per hour. Now be very careful with units. You can see how in the solution, I try to maintain the unit. Now your mass flow rate, 100 kilogram per hour, times your specific heat, 4.2 kilojoule per kilogram, times your change in temperature, right? That's 1 over change in temperature is 100 degree centigrade over 1, right? So if you cancel this temperature, it goes out. You cancel the kg, it goes out. So what is remaining is kilojoule per hour. You don't have to throw it away. It's still part of your answer. Now, the question is asking you to provide this answer in kilowatt. So you need to convert this to kilowatt. Now, remember that, remember when I said that 3.6 kilojoule is equal to 1 kilowatt hour. So replace this 33,600 kilojoule, replace it by kilowatt hour.
9.33.
9.3, perfect. 9.33 kilowatt hour, correct?
Yeah.
So the hour, we cancel the hour. You will not be left with what? Only kilowatt. Is that correct? So this is the answer. This is the calculation. This is how you solve the question. You say now when you convert by 3,600 kilojoule to kilowatt hour, what you have is 9.33 kilowatt hour. Now this is 9.3 kilowatt hour. You divide it by the hour. So this hour we cancel this hour. What you're left with is 9.33 kilowatt. Okay. Okay. So any questions so far? Okay, just keep looking at this. If you have any question, just give me 30 seconds. I'll be back. 30 seconds. I need to check on something. Okay, so I'm back. Any questions so far? No questions. Thank you. Okay, so let us look at energy losses in boilers. Now we've looked at how boilers work, the energy transfer systems in boilers. Now let us look at energy losses in the boiler system. So these are the two kinds of boilers, like I said. Now, what are the energy sources and what are the ranges of losses that actually occur in some of these? So the second column, you're going to have heat in flue gases. Now, the flue gas are the gases of combustion that actually leave through the stack or through the exhaust pipe. So those are the heat in flue gases, right? Now, who is drawing on my screen? David, please. So when you combust or when you burn any sort of fuel, the flue gas actually contains, so in some cases, high amount of heat, and you send it out into the environment. So this presents a huge source of heat loss in the system. And there's also heat in the moisture content of the flue. Now, remember when we looked at the chemical process of combustion. Thank you very much for erasing it. When you look through the chemical process of combustion, you would see that water is also a product of combustion. And that water is not visible. It's like a moisture. I mean, it's like, yeah, because it's passing through a high temperature. So it's not the kind of water that flows. So it's like a steam, but it's actually water. Now, steam, whether in the form of steam or water, still have the same chemical formula, which is H2O. Whether it's in the form of steam or in the form of liquid water, it has the same chemical formula, which is H2O. However, that their temperatures varies. Okay, so now remember the water that is coming out of that combustion that is also being sent out through the flue system also contains a loss of energy. So now what is the quantity of energy that loss that could occur in this? It could get up to 35% energy that is being lost through that flue gas, right? So the factor is exit temperature or excess air that is leaving through the flue gas. Now the next one is incomplete combustion. Remember, I talked about incomplete combustion and I explained that extensively. So about 1% of your energy could go through incomplete combustion. How do you know? You can know that through the CO2 in the flue gas, measuring the CO2 in the flue gas. There's another one that is known as blow down water. In some times, so for some of us who, if you have used kettle, I don't think is a problem in Nigeria, but if you've gone abroad and especially in Europe, if you use kettle and you keep boiling water constantly, you begin to notice there are some things that are forming, something like scales that are forming at the bottom, right? So we keep boiling those, you see those scales. Now, in industries, is a big problem when you keep, because you're constantly converting water to steam. After some time, those things will not settle at the bottom of or within the boilers, and you need to remove them. If you don't remove them, they will create problem in your system. So the process of removing them is what is known as blow down. So you need to more like, open the boiler to flush those things out momentarily. So in the process of doing that, you're losing heat, and that's known as blow down water, which you can lose up to 6% of your heat. Okay. Now there's radiation from the boiler surface. If you've been to any industrial boiler, if you move around the boiler, you will notice that the surface of the boiler is, despite the fact they pad it, they try to make sure the heat loss is reduced, but you can still feel, the heat, if it's not, done very well. So radiation from the boiler surface could also result to losing of heat. Then combustions in ash, if you're using coal or biomass as your fuel in boilers, there are some incomplete combustion or some radiations from the or some combustible ashes that are not completely burnt that also go out. Again, there's part loading of the boiler. The same way you part load your generator and it increases the inefficiency. You can, if you part load your boiler, you also increase the inefficiency. So these are the different ways of examining, the efficiency of a boiler and making sure that some of these energy losses are curtailed. If you do this very well, you actually reduce the energy consumption of the boiler. The most important one, you can look at the most important one, which is the heat from the flue gas. You can see that can go as much as 35%. So it's very, very important that you look at that. How do you recover the heat from the flue gas? So we are going to look at how to recover the heat from the flue gas. So now we're talking about energy opportunities in the boiler system. So there's what called installation of economizer. I will explain what that means. Installation of economizer, combustion air preheat. Remember combustion, you need oxygen, so you need to introduce air. But imagine that the air that you're introducing is already preheated. It will increase the efficiency of the process. And that heat that the air contains will already be transferred, into converting the water to steam quickly. There's combustion control, there's blow down optimization, heat recovery, there's installation or repair of insulation, there's load management, there's variable speed drive or fan. We're going to explain some of this as we proceed in the training. There's boiler replacement. If you have old inefficient boiler that is more than maybe 20 years or even maybe 15 or 10 years that is inefficient, it's in some cases it makes sense to replace them. In other cases, you might just have to retrofit them. Okay, you might not necessarily need to replace them. You might need to retrofit with some certain technologies, to make them more efficient. So there's also general housekeeping measures. Now I talked about economizer. If you look at this, the number one there is installation of economizer. Now let us look at what that means. Now this is your boiler, right? Now this is the flue. This is the flue gas. This is where the flue gas leaves